Welcome back, my viewers. So we are now on basic laws of what probability. So let's look at the basic laws of what probability. So this basic laws is basically the axioms of what probability. This is basically the axioms of probability. So that's it, saying the same thing. So they mean that probability of an event or the probability of an event must not exceed what 1. So that's what it's trying to tell us. The probability of an event A, usually written as P of A, is always a number between 1 and 0. So it must not exceed 1. Probability of A must be greater than or equals to 0. And probability of A is less than or equals to 1. And that for a sure probability that this thing will happen, certainty in probability is equals to 1, then that it will not happen is equals to what? 0. So if P of an event to occur is equals to what? 1. Probability of an event is equals to 1. This implies certainty that is being 100% what? Sure that the thing will happen. So if P of an event is equals to 0, this implies that impossibility. This implies an impossibility that the event will never do what? Occur. So for event to not occur, it means what? 0. So example, the probability of the month of February having 30 days. You know that they tell us that February have how many days? 28 days, then 29 in leap year. Now you saying that February will have 30 days. You see that it will not occur, it will never occur. And again, probability of saying that women are priests in Catholic Church, is never possible. Or probability of you saying that all men will not die, must not die, or something like that, and you know that it is not true that all men must die one day. So these are the impossibilities. The probability that a particular event A will occur is 1 minus the probability that a particular event A will not occur is equals to 1 minus the probability that A will do what? Occur. So that is 1 minus the probability of the event occurring, of the event A occurring. Then this is usually represented by probability of A is equal to 1 minus probability of what? 1 is represented by probability of A prime. A prime means the opposite of what? A, that it will not occur. A prime is equal to 1 minus probability of A occurring. Where A dash like this, read as what? A prime is the complement of what? A. So this is how the probability is. Probability of an event occurring plus probability of the event not occurring is equals to 1. So probability of A plus is equals to 1 minus probability of this one is not occurring. So I'm going to put prime of it not occurring. So probability of it occurring is equals to 1 minus probability of it not occurring, and probability of it not occurring is equals to 1 minus probability of it occurring. You understand? So that's it. So in a throw of a die, if a 2 is obtained, what is the probability of not obtaining a 2 in the same throw? So probability of you not obtaining 2 in the same throw, probability of obtaining 2 plus probability of you not obtaining 2 is equals to 1. So probability, what's the probability of not obtaining 2? So probability of not obtaining 2 is equals to 1 minus probability of you obtaining 2. That's a simple solution. So you know that in a die, probability of you obtaining 2 is what? In a die we have what? 6. So probability of you obtaining 2 is equals to 1 over 6. You get? So it will now be 1. Probability of you obtaining 2 is what? 1 over 6. Put it here. So probability of you not obtaining 2 will be 1 minus 1 over 6, which will give us 6 times 1, 6 minus 1 over 6. 6 minus 1, which is 5 over 6. Answer. So that's the correct answer to this question. Let's solve another question regarding to this quickly. So the second question, in a toss of a coin, what is the probability of obtaining a head? So solution, remember, probability of obtaining a head plus probability of obtaining a tail. Sorry, of probability of you not obtaining a head is equals to 1 minus, is equals to, sorry, 1, right? So probability, what they ask you of obtaining a head is equals to 1 minus probability of you not obtaining what? A head. Now, probability of obtaining a head, you know now, in a coin, the sample space is what? Head and what? Tail. So the sample space is what? 2, right? Over 2. So obtaining a head is what? 1 over 2. Obtaining a tail is still 1 over 2. So we're going to have obtaining a head is what? 1 over 2 is equals to 1 minus probability of you not obtaining a head will now be 1 minus probability of you obtaining what? A head, right? Okay, probability of you obtaining a head is equals to 1 minus probability of you not obtaining a head. So probability, what they even ask, what's the probability of obtaining a head? So it will be probability of obtaining a head is equals to 1 minus probability of you not obtaining a head, right? So it will now be 1 minus 1 over 2. So in a toss of a coin, what is probability of obtaining a head? So probability of obtaining a head, probability of obtaining a head plus probability of not obtaining a head is equals to 1. So probability of obtaining a head is equals to 1 minus probability of not obtaining a head, and probability of not obtaining a head is equals to 1 minus probability of obtaining what? A head. So probability of not obtaining a head is equals to, probability of obtaining a head is 1 over what? 2. So we have 2 minus 1 over 2, which is what? 1 over 2. Therefore, probability of not obtaining a head will now be, of obtaining a head, probability of obtaining a head is equals to 1 minus probability of you not obtaining a head, which is same thing as what? 1 over 2. So that's the answer. Thank you for watching and God bless you. Bye bye.